Okay, as it was said, I'm going to talk about the digital technologies. It's a very wide topic, so I'll try to show different services that are relevant for the economy sector, and it's mainly based on the services that we are providing to different stakeholders in this sector. And it's based, in addition to MarTe results, we have these different projects, which all are dedicated to building the different components of the digital twin of the ocean. So we have the EcoDT, which is providing the ecological aspect of the sea areas. Then we have the TEMTA, which is digital twin for offshore renewable energy, not only wind, but others as well. And then we have the European projects TerraDT and TTO for OVA, which are targeted at offshore wind energy sectors. So all of them are user driven. So what the users want or what we can provide. But I will pick some other stuff as well in the here. So why digital services in blue economy sector? So the need for this kind of services stems from two approaches, at least according to my opinion. So we have the business-driven need for optimizing the offshore construction or making them efficient and assessing what will be the servicing windows for offshore constructions or so on and so forth, or safe navigation for ports. And then we have these kind of legislative drivers, which are related to environmental impact assessment, environmental protection, climate change impacts, and so on and so forth. So usually businesses would like to deal only with the first one. National authorities require the second one as well. So these kind of digital services need to address both of these needs. And depending on the development, also the spatial scales of the service and temporal scales are different. So if you need operational information for navigation, it's 1-2 days online monitoring and forecasting. When you need spatial planning of marine space, then you need large scale, long-term data sets and data analysis. So there are plenty of these kind of different services applications. The idea nowadays is, or the main challenge is, how to combine all these different environmental information in digital twin of the ocean, let's say, or digital twin of the sea. We talk about the Baltic. And that is what we are dealing with quite a lot. And there are challenges, but there are also, let's say, success stories. But probably you all have seen different kind of met-ocean services or data analysis and digital tools. So from our perspective there, as I said in the previous slide, we have here the global scale, the Baltic Sea regional scale, and which is relevant for authorities usually. And then we have these kind of local applications, which are relevant for specific developer and what he or she is interested in. And this can be also temporal scales. We can have this kind of long-term global analysis of climate. We can also have these operational services, at least in Estonia. We have seen a couple of examples here where we have either from EU, Copernicus Marine Services, a data source, and then we have the national forecasting and monitoring services. So that we can use. And also there is with the digital twins and digital services, we have to consider all of the information, or not all, but as much as possible. Usually it contains online observations, measurements over the large area and domain. Then we have the satellite data for monitoring the surface processes, and we have the modeling component, so that we could have this kind of total digital replica of the marine environment. Here is one example. So again, about satellite imagery, we have water quality monitoring in the LNG terminal construction site, on the upper side, which is driven by the legislative requirements. So the environmental monitoring requires these kind of monitoring services. Another one is regular water quality monitoring. Again, both are great examples where satellite imagery, which is like a year, once a week or so in cloud-free conditions, we can have that. How satellite imagery can improve the monitoring or building the digital twin. So either for monitoring the impact of construction works or doing the routine monitoring of the water quality, in this case in Lake Ülemiste in Estonia. Again, we have all these different components. Now we would like to build one holistic approach, which is the digital twin. The first question always is, what is the digital twin of ocean, or with any other digital twin, what is the purpose of the digital twin? And in this case, we are talking about the digital twin of the ocean, not digital twin of the port or something else. So, and for that, the purpose of DTO is to provide digital replica. So what is the situation now? Then provide future scenarios, what will happen in the future, and then analyze the what if scenarios. What happens if we build something in the sea? What happens if we don't do that? So these are the main three large questions that DTO should be able to answer. Otherwise, it's just a set of different tools. And therefore, we are, let's say, moving forward with this. And so the general applications or purposes of DTOs are to better plan the sea area and assess the human impacts, be prepared for any kind of risks or hazardous events, and in large scale assure safety at sea, and be, let's say, have a decent maritime spatial planning so that all parties are more or less happy. Nobody is very happy. And this is quite challenging because all different user groups or parties have their own opinion how we should manage the sea area. But with the digital twin, we can, let's say, provide this kind of information about what will happen if we do different developments in the sea area. So one specific case for Estonia is marine ecology digital twin, where we analyze the ecological effects. So this is more, let's say, targeted to the authorities or national authorities or state authorities. So what will be the impacts if we use our marine space in one way or the other way? So relying on the information that we have. So we'll build a prototype, but and then use it for different use cases. So for harmful algal blooms, for cumulative effects of wind farms, ecosystem services, estimating the potential of aquaculture and fishing and their impacts, and so on and so forth. And in one other project, which is TEMTA, digital twin for offshore renewable energy, we look at the aspects of marine heat resources for heating and cooling in the living areas, and wave energy potential, and so on and so forth. So different use cases, and we would be very happy if different stakeholders who find it relevant would, let's say, give their feedback and let us know if they are interested in one or many of these applications. So then we can have you as a pilot users. So here is one use case of determining the resource of energy using marine heat for heating and cooling the coastal buildings. Quite a stable solution in Estonia. One development in Tallinn currently, we're doing the study for them. So, and the idea is to, from this digital twin dataset, to identify the number of days which are suitable for heating or cooling in the summer of the buildings. And this is also, again, estimating how the energy potential in the sea area is distributed and how and where it's reasonable to use. And of course, there is the other aspect, so how the water intake and outlet will affect the marine environment. So again, this aspect that the developer is interested in, what is the resource in the sea, the water that he takes in, and the authorities are more interested in what will be the impact if the water goes back to the sea again. So that's why we need these kind of digital twin approaches to cover both sides. So cumulative effects and what will be satisfying for both the authorities and companies. So if you're interested in this kind of application, as I listed here a couple of slides ago, then feel free to let us know by answering this very, very short questionnaire. And we'll try to bring your interest in the projects and try to answer these as much as possible. But I would like to give you one more example, so which stems from the needs during this year. So the most suitable topic for late spring, early summer is, of course, sea ice. So this is one aspect that was kind of surprising for us, not for us, but for many other stakeholders. So within the context of climate change, stakeholders started to think that sea ice is not relevant anymore. That's not the case. We have this project called TTO for offshore wind energy, where we have these developers, partners, Vattenfall, RWE, Equinor. And so we had this kind of study. So what are the relevant parameters that they need for their metocean studies when they start planning and designing the wind farms? And surprisingly, the most popular answer was sea ice. And the reason for that is that all the other parameters are first quite well studied already, and people know about that, or the developers know at least. And sea ice is a gap, let's say. And secondly, I think that the developers are moving towards north with the offshore wind energy sector. So in the areas where the sea ice is relevant. So That is why this kind of information of sea ice conditions is relevant. And the third point is when they start offshore operations or the wind farm will be operating, then they need sea ice information for servicing, and they need operational forecasts. This is just one digital twin simulations for this winter, the whole winter in the Estonian waters. Maybe you have seen it, maybe not. And it was, let's say, very interesting for us to see that DTO sea ice information that we created agrees very well with the satellite observations that are provided by the national agencies and Copernicus Marine Service. So therefore, I think in some cases or many cases, we have these, let's say, very good success stories already. Where we have the operational stuff, and also when we have these kind of cumulative studies. Here again, one example for Gulf of Riga, where we had to simulate the rich ice impact when we have two different wind farms, so to assess the cumulative effects. Very challenging, as Christian probably also knows. But this kind of cumulative impact is where we are, or the sector is also obliged to take into account, as it comes from the state or regional authorities, the requirements, what are the cumulative impacts. And in the DTO project also, we have the cumulative impacts in the previous slides about sea ice. And also then we have the cumulative impacts of the wake effects. So if we build all the places where you have these dots here are potential wind farms, we carried out the simulation, what will happen? So how will the surface currents change, increase, decrease? Again, if you have one wind farm, doesn't matter maybe. But if you have a lot of them, then they will change the nature of the sea or how it behaves. And then these are the things that will affect the ecosystems. Again, something that we have to consider if we want to preserve or achieve the clean, good status of the Baltic Sea. So again, it's just in a nutshell. The important part is in the red. So there are very many digital service components which need to be combined into one holistic DTO, which would then enable to support the knowledge-based decision-making across the blue economy sectors. So this is where we are targeting at, but it's very challenging and long road. But we will get there. It's not impossible. Thank you.
Great, thank you, and thank you for staying in time. Very fascinating and very helpful in terms of supporting the development and implementation of different technologies, so that we can take into account the different environmental impacts. Do we have one quick question for Rivo? People are too shy, or they're just baffled. But nevertheless, thank you. I have one question. Do you think there is a gap in people's ability to use the digital technologies that are being rapidly developed? Do you think it's the people who are becoming the bottleneck in starting to use these different tools that we are developing? Or it's not an issue?
You mean the users or stakeholders, let's say?
Yes. Yeah.
Yeah.
Yes.
We don't have the people problem in the development part, so we can develop these kind of services. The question is, if the users think that it's too complicated, then it's the matter for the developer to make it simple and usable. So it's kind of, I wouldn't blame the users.
Okay,
So
the developers can do
they
just a little bit better.
Yeah, they just should express what they would like to have. So, and then it's up to the developers to provide that. I would go in that way. But our experience is that the user requirements are very diverse. So with this project, as I mentioned, we have some cases where the users would like to have very basic and simple stuff, and then the wind farm developers would like to have something which seems almost scientific, so very advanced input. So which is also good. So, but then we have to answer to these questions differently.
Yeah, absolutely, very different needs. Okay, thank you.